Hello and welcome to Advanced Digital System Design playlist. Today we're going to be studying about T-Flipflop. The T-Flipflop is also known as toggle flip-flop. To avoid the occurrence of intermediate state in SR flip-flop, we should provide only one input to the flip-flop, called trigger input or toggle input. Then flip-flop acts as toggle switch. Usually what we do in SR flip-flop, we replace the inputs by only one input to flip-flop, which is called the trigger input or toggle input. Then the flip-flop acts as a toggle switch. When J is equal to K is equal to 1, we have only one input, which is the toggle input. That is when J is equal to K is equal to 1 in JK Flipflop, we get the toggle flip-flop, and in which has only one input. This diagram shows the block diagram of the toggle flip-flop with only one input, that is the T input, and a clock. The outputs are given as Q and Q bar. Now let's move to the logic diagram. The logic diagram is similar to the JK flip-flop, having 2 3 input NAND gates and a latch, but here as in JK flip-flop we had a J here, K here. Here J is equal to K is equal to 1, and it's set to 1, which is the only input in the toggle flip-flop, or the toggle input. The characteristic table of the toggle flip-flop is given as we read the 4 combinations 0 0, 0 1, 1 0 and 1 1. And for toggle flip-flop we have to remember Qn plus 1 is equal to 0 for 0 input, and 1 for 0 1 input, and it's 1 for 1 0 input, and it's 0 for 1 1 input. In short, for toggle flip-flop we have the next state Qn plus 1 is equal to 1 only when the inputs are different. When the inputs are same, we have 0 as Qn plus 1. We can also get simplified truth table from the characteristics table itself. Here we have 2 combinations 0 1, and the T, when the input T is equal to 0, the Qn plus 1 is equal to Qn, and when the input T is equal to 1, Qn plus 1 is equal to Qn bar, which means when the input T is equal to 0, that means these 2 combinations, Qn plus 1 is equal to Qn. This Qn plus 1 is equal to Qn, 0 1 0 1. And when the input for T is 1, that means these 2 combinations, the Qn plus 1 is equal to Qn bar. That means 0 will become 1 and 1 will become 0. Now we get the characteristics equation by solving the K-map from the characteristic table. What we have 4 cells. In cell number 1 we have 0, in cell number 2 we have 1, in cell number 3 we have 1, and in cell number 4 we have 0. So in cell number 1, in cell number 0 we have 0, in cell number 1 we have 1, in cell number 2 we have 1, and in cell number 3 we have 0. After necessary grouping of these cells, we get the characteristic equation of the T flip-flop as Qn plus 1 is equal to T Qn bar plus T bar Qn. As we know, T Q bar plus T bar Qn is equal to T XOR Qn. Now the excitation table of the T flip-flop can be found from the characteristics table. We plot the necessary inputs, that is the present state, current state and the next state. We give the 4 combinations 0 0 0 1 1 0 and 1 1, and we check for the corresponding 0 0 0 1 1 0 and 1 1 entries in the characteristic table and give the corresponding values of the input T. Here we first see the 0 0. We look for 0 0 in the characteristics table. We find 0 0 is here, and we write 0 in the T section of the excitation table. Here we write 0 for 0 0, we have 0, and for 0 1 we check the 0 1 entry in the characteristic table. Here we check the 0 1 entry. For 0 1 entry it is 1, so we write 1 here in the T set. Now we check for 1 0 entry in the characteristic table. 1 0 is here and its input is 1, so we write 1 for 1 0 1 as in the T section. And for last entry 1 1, we check it in characteristic table. 1 1 1 1 is here, and we see the corresponding input value for the 1 1 combination is 0, so we write 0 for the last 1 1 combination. After that we draw a state diagram using this excitation table. What we do is we check the corresponding initial state and the next state. Here initial state is 0, next state is 0. Here initial state is 0 and the next state will be 0 itself. That is the self loop at 0. For the input t is equal to 0. For input t is equal to 0, we write that on the arrow. Next entry is initial value 0, next value is 1. Initial value 0, and the next value is 1. We draw an arrow from 0 to 1. For the input t is equal to 1, we write t is equal to 1 above the arrow. Next we have for 1 0, initial state 1 and final state 0. Initial state is 1, we start from the 1, and the final state is 0, we end up at the 0. For the input t is equal to 1, for the input t is equal to 1, and for the last entry we have 1 1, initial state 1 and the final state 1. We start from 0 and end up at we start at 1 and end up at 1 itself. So we have a self loop at 1 for the input t is equal to 0, for the input t is equal to 0. This completes the state diagram of the T flip-flop. That's all for this lecture. I hope it's informative for you. I'd like to thank you, and please do subscribe and like.
Subscribe now and press the bell icon. Never miss an update.